In this video, we're going to show how to find the sides of a 30, 60, 90 triangle. And we learned this in Unit 8. I think this was lesson 8.06. Before we begin the video, I just want to remind you that this is the way that I showed you the last time. That if we had like a, remember we had small triangle, medium triangle, large triangle, and we called this the medium triangle. It's like a reference triangle. And if we knew, for example, that the side opposite the 30 degrees here were 8, then we could write a proportion. Let's say we were trying to find the side opposite the 60. So we could call this like L for leg. And we could then write a proportion that would be radical 1 over radical 3 equal 8 over L. So that would look like this. And then we would be able to cross multiply, and we would have a radical in the denominator. We'd have to take care of that and solve, and we would get it. So I told you that the way that you could remember this, what the different sides for a 30, 60, 90 and for a 45, 45, 90 triangle are thinking of across from a 30 is radical 1, across from 45 radical 2, radical 3, and radical 4. And then of course radical 1 is the number 1, and radical 4 is the number 2. So across from the 30 is 1, and so on. So just to let you know, if you remember that, that still works. But now I want to show you another way to figure all of this out. And at the end of the problem, we will have our answer in terms of h. So whatever we take h and multiply it by a certain number to get this side, and take h and multiply by a different number to get this side. But before we do that, we're going to use the number 4 to represent our hypotenuse, because it's going to be pretty easy to work with. We know that if this is 90 and this is 60 degrees, then this is also 30 degrees. Now, instead of trying to memorize how to get there, what we can do is we can draw an identical 30, 60, 90 triangle here. I want you to imagine that this is a perfect reflection. This. So if we reflect over this, then 90 reflects to 90, 60 reflects to 60, and 30 reflects to 30. Now, we should now see that we've made an equilateral triangle. So with the equilateral triangle, we know that if this side is 4, then across from this 60-degree angle must also be 4. Across from this 60-degree angle must also be 4. Okay. Now the reason it's helpful for us to know that we have an equilateral triangle with sides equal 4 is we can then say that if this is 4, then this must be 2 and 2. So this tells us one thing that we can always figure out easily about a right triangle, or rather a 30, 60, 90 triangle, that if we make it an equilateral triangle by copying it across, we could see that we would have all sides the same. And so then this little piece would be half, exactly half of this full thing. So this tells us that whatever we have across from the 90, our hypotenuse should be divided by 2 to give us across from the 30-degree angle. And if we know what is across from the 30-degree angle, we would multiply it by 2 to get the hypotenuse. Finally, this is a right triangle, and we know 2 sides. So we can find the third side by using the Pythagorean theorem. So we have the short leg and the long leg. So we can say short leg square plus long leg square equals hypotenuse squared. And we can substitute the values that we know. So we have 2 square plus L square equals 4 square. We have 4 plus L square equals 16. Subtract 4 from both sides and get L square equals 12. take the square root of both sides, get L equals square root of 12 equals square root of 4 square root of 3 equals 2 radical 3. So we know that this leg is 2 radical 3. So if we had a hypotenuse equal 4, then we would have the short leg of 2 and the long leg of 2 radical 3. And this is only for 30, 60, 90 triangles. Now what I want to do is I want to show you how you could get your sides for any lengths of 30, 60, 90. So let's take this and make it a different number and see what else happens. So let's call this H. If this is H, then this must be 4 divided by 2. So this is H over 2. Then finally, this 2 is H over 2. So this 2, H over 2, radical 3. Or if you prefer to write as a fraction, that radical 3 is multiplying by H. So that radical 3 can go in the numerator. So this is the same as H radical 3 over 2. So this is telling us that whatever we have for the hypotenuse, we can divide that by 2 to get the short leg across from the 30 degree. And we can take that and divide it by 2, but then multiply by radical 3 to get the long leg. So this is another way that you can figure out a 30, 60, 90 if you forget about it and you haven't memorized it. So again, start with a 30, 60, 90. Then choose a length for the hypotenuse. Then make it an equilateral triangle. Then see that you have 3 and 3 because this is a duplicate of this. Then take this away and use Pythagorean theorem to find the third side.